computing network types, okay? So I'll be keeping the theory at the beginning. We'll be back there. So let's go and do the example. It's the same example that we draw the network. What's happened with the table that you can see on your screen? You can see that now there is a fourth column called activity type. That fourth column is called activity type. So you have the same stuff we had before plus the activity type. And what does it mean? Like say, activity A takes 5 days, okay? Activity B, 15 days. So now we have the sequence and the duration. The complication over the example in which we have a linear path is here because you have tasks that start and finish, and so you have several paths interrelated. And that's what is the problem here. We cannot go and just add the durations up until the end. We have to do another kind of calculation here. And that calculation is just, let's try to do some kind of example here. So if activity A, can you see me here? Activity A takes 5 days, and I start a project on day 0. So I have to wait 5 days to start the other activities. Okay, so if here I start on day 0, I have to wait 5 days to start the other activities. And activity B takes 15 days, so I will be start on day 5 plus 15 days. I'll be finished on day 20. Activity C, I have 10 days. I'll be finished on day 15. Now I have 2 activities that are predecessors of E. When can I start activity E here? 20. Yes, because activity D depends on B and C. So, okay, I can finish the activity C on day 15, but the activity B is still ongoing, and will be finished just 5 days later. So I have to wait for activity B to start C. So I'll be starting C in the 20. So what we mean by computing network time is to figure out when each activity can start and finish in the network. It's not a direct computation like we did in the first network. Here we have to consider if there is a merge or a burst activity and understand what's going on. So what we'll be doing now is applying that, and there is a technique for that, and we will be applying that technique to compute the times for the network. This is usually done inside MS project, so it's behind the scenes. So that MS project has the algorithm to compute those things, but we need to know what's going on there, because sometimes we may face a problem. So what I'll be doing now, I will be redrawing that network in a bigger box. Just do that, and then I'll be showing you what kind of symbol we use and all the information we can get from computing the project network. The book uses a notation with a certain symbols that we will be using in our course. So let's come back and try to understand the notation. So here the notation is a square in which we have the activity ID. Oh, sorry. Activity ID here, that square, Then we have the duration we put here in the middle. We have two horizontal lines, and we have another vertical line here, and another one that stops here, and from here up. And in the middle, we put the description of the activity, okay? That's the name of the activity. Here is the ID, means activity 1, 2, 3, 4, 5, 6. If you are in a WBS, you may use activity 1.1.2, depending on the level, depending on the subdeliverable in which that activity is linked. And so, and you have in that square some numbers that you'll be computing during the process. We have ES, that means early start, EF, early finish, LS, late start, LF, late finish, and slack. So that is the network. That is the network. Now, using the notation of the book, we have that network here. Again, it's still a activity node. I'm using the notation of the book in which you have the activity ID, duration for all the activities. And what we have to do now is compute the durations, okay? And I'll be just explaining. Let me put some kind of a small thing here that would be like a calendar, okay? A calendar on the bottom here, because we need to, I like to use that so you can understand. So you will have here. So in that calendar, that small calendar, let's put that the duration here. We have, so I start of the project, that's the first line. Then the second line, so the start of the project is here. So we start at the beginning of the first day. Then after 24 hours, we finish the first day. When you finish the first day, we start the second day. At the end of the second day, we have second day, third day, fourth, 5, 6, and on. And in the calendar, let's write here the activities: activity A, activity B, and activity C. This is just to help me to understand what I will be doing here on the top. We will be, so just the beginning, so, and then we can catch up. So what's happened? We always start at the beginning of first day, and then we'll be understand why I'm using that strange language, okay? Hold on a second. And here, so we always start on time 0. That's the beginning of first day. So activity A will start on time 0. Activity A has a duration of 5 days. So let's see here how it works. So I start time 0, 1 day, second day, third day, fourth day, and fifth day. So I start on time 0, work for the first day entirely, then I finish the first day, start the second day, and so on. So I'll be finishing activity A on day 5. So it's the same, I say 0 plus 5, 5. What does it mean? What does it mean? That I start activity A on day 0, the duration 5, 0 plus 5. I will be finishing activity A on day 5. And here, when I should start activity B, I will be start activity B right after activity B. So A would be starting on day 5. So what happened when you use that technique? So I finished activity A on day 5, and I start activity B on day 5. Actually, I finished just before, at the end of day 5. So the 5 start here. That's morning of day 5, afternoon of day 5, okay? And then I finish day 5. So I start here at the beginning of day 6, but after day 5, okay? And so the same thing here, we have to start. So we can start activity C when I finish A. So I start C on day 5. The same thing for D. I can start D after activity A, or I'll be starting D on day 5. When can I finish activity B? I can finish activity B when I go from 5 plus 15, 20. 20, day 20. When can I finish activity C? When? 5 plus 10, day 15. When can I finish activity D? I will start on day 5, use 5 days duration, I'll be finished on day 10. Okay? That's we do the computation and understanding the times. So what I'm looking now is try to understand for each task what we call early start and early finish. Is the earliest time that I can start the activity. For here, like say activity B, the earliest time that I can start B is on day 5. Why? Why? Because I have to wait the execution of activity A. Okay? Let's move forward. Let's move forward. Activity E. Activity E. And now I have something to think about. Activity E. I have to wait for B and C. B will be finishing on day 20. C will be finishing on day 15. Okay? So because E has to wait the conclusion of tasks B and C, here I have to wait for the longest period. The longest period. So between the two, I will take the highest. Again, I cannot start on day 15. Although C will be finished by day 15, I cannot start because I have to wait for activity B. And that's why I have to take the longest time of all preceding activities to determine the early start of a merge activity. Okay? So tell me for activity F. Tell me for activity F. So F has to wait for B, have to wait the conclusion of C, and then conclusion of D. What's the early start for activity F? Okay, 10. Oh, Francisco, 10, you put 10. 20. Oh, Francisco, so that's a finger problem. That's why I like Francisco, you know? He's following me. He put something wrong just to check if you are paying attention. Like me. It's exactly what I do. That's okay, Francisco. Okay, so 20 plus 10, 30th. And here 20 plus 15, 35. And now move forward in the network. 30, so G can start on 30. When can I finish G? When can I finish G? 200. Yes, 200. 30 plus 170, 200. And now we have H. When can I start activity H? Who knows? We have two activities that are preceding H, activity E and activity G. Yes, exactly, my good friends, 200. And now the end will be 245. 200 plus 35, 235. So what we just done is to compute the network times in what we call a forward path. When you say a forward path, is a forward path. In that forward path, we are calculating the early start. It means the earliest date that the activity can start and the earliest date that the activity can finish. Once we do throughout the project network up to the end, we have the project duration. So here we go for 235. That is the project duration. Okay? That is what we call forward path. Is that okay? Doubts? Let's just take my coffee here. Victoria, all good. Francisco, okay. Okay. So that's the backward path. Do you know Michael Jackson? Do you know Michael Jackson? Have you seen Michael Jackson before? And now, for Michael Jackson is the moonwalk, but this is the backward computation. The backward computation, we go from activity, the end of the project, back to the beginning. That is the backward project. It's not Michael Jackson, but it's similar, okay? It's not Michael Jackson, but it's similar. Okay, so that is what we call backward computation. And what is the backward computation? Now the backward computation, we start from the end date of the project and start subtracting the durations of each activity until the beginning of the project. And that type of computation will give us another type of information that's very useful when we are doing project scheduling. Okay, so let's start. I'm using the green to show that. So we start with the end day of the project, that's 235, day 235, and you'll be subtracting and moving from 235 minus 35, it is 200, okay? 200. And now I'll be moving back on the arrow. So don't put another arrow here, just see. Moving back on the arrow. So from the arrow to the starting point of the arrow, and we'll be going with the that time. And so that time on the bottom here, we call that late times. The first one is the late finish. So it's the latest finish that the activity can be done. And the other side is the late start. It's the latest day that the activity can start without delaying the next activity. Or without delaying the project, okay? Without delaying the project. We go from, so we move back. So backward, we go from, put the 200 here, and the 200 here. The activity G and activity E. So now we go for activity G. 200 minus 170 is 30. It means that the latest time that activity G can finish is 200, and the latest time that the activity G can start without delaying the project is day 30. That's no news so far. But if you go for activity E, we will see some kind of different picture. And the picture here is that 200 minus 15, we have 185. And that is I'll be back to your question. I can see here, okay, Gabriela. And so let's just work here on activity E and try to understand what does it mean. We have here 20, 35, 200, and 185. The 20 is the early start. The 35 is the early finish. So the 35 is the earliest day that I can finish the task. The 20 is the early time in which that I can start the task. I have to wait all the network to arrive here. So that's the earliest time. 200 is the late finish. It means that I cannot finish that task after that day. If I finish after that day, I will be delaying the project. That is the late finish. And here, 185 is the late start. considering that the task has a duration of 15 days, the late start is 185. So we have a difference between the early start and the late start. What does it mean? Pay attention. What does it mean? It gives the project manager some flexibility to schedule the task. What do I mean by that? So here, that task has a duration of 15 days. I can put that 15 days in the project schedule between day 20 and day 185, anytime. Sometimes the person is not available. Sometimes you don't have equipment available on a certain day and just 5 days later. And so you have some flexibility to schedule the starting date of activity E. So the project manager with that information can try to figure out a better schedule, a better day to do a task. For task E, the project manager has flexibility. For task G, no. Task G has no room, has to start on day 30 and finish on day 200, okay? And is that okay? Let's go for some questions here. Javaria said, so the late start finish isn't the, so the late start finish, oh, you got it now. So, but let's see, late start finish isn't the estimated worst case scenario times. So the late start is just, so you have that information and you can play with that information, okay? Just give you an idea if you must start on that day or if you have some flexibility to schedule the task. Okay, let's conclude here the calculation here. So 30, we move back on the, 30 minus 10, 20, okay? And now we start to have 20 here, and we have to move 20 back in all the lines. 20 come here, and I'll be moving 20 back in all our arrows, okay? 20 here. And then I take that 185 and move back, 185, back. Now we have, for some activities like activity D, it's easy. I put 20 here, there is no other condition. But for activity B, I have two late starts that I have to pick one. One that day 20 and another one that day 185. Which one should I pick as a late finish for activity B? 20. Very good. 20. Why? Because that's the late. If I pick something above 20, I will be delaying activity F. So I cannot delay any task, so I go 20 here. The same thing here. So we go, subtract 15, we have 5. Subtract 10, we have 10. And then we have 20 minus 5, 15. And then we move back to the activity A. We have 5 here from activity B, 10 from activity C, and 15 from activity D. Which one should I pick? The smallest one. I cannot delay B. So I take 5 and 0. So that is the backward path when we are computing the project network. And here, is that okay? Is that okay? Is that okay, guys? Are you still there? Okay? Did you like the Michael Jackson? I know that. Okay. And so, and now let's do another type of, let's explore all the data that we got from that computation. We can now subtract the early times from the late time. Like here, we have 0. Here, we have 0. Activity F, 0. Activity E, we have 165 days. Activity D, we have 10. Activity C, we have 5. Activity D, 0 and 0. So we have here some activity that there are no flexibility, no room for delay, no room for schedule the activity start or finish. Those activities we call critical activities. And those activities are in the critical path. So we have some critical activities. H, G, F, then we go for B and A. So if you put here a line, we can trace the critical path in the network. The critical path is the path with the activities that I cannot, I don't have room to change. And that number that we put here in red, we call that slack. Okay, slack. We did the forward path, and then we did the backward path. And doing these two computation, we got a lot of information about our network that will help the project manager to find a better and suitable date for each task. What kind of question can we answer when you finish the forward path? We can, so how soon can the activity start? One question that can be answered now. How soon can an activity finish? How soon can the project finish? What are the questions that can be answered once we do the backward path? How late can the activity start? How late can the activity finish? Which activities represent the critical path? How long can an activity be delayed? Of course, without delaying the project. So those questions